I'm Alex Strauss, and welcome to the Le Chatelier's Principle Lab. Before we get started on the lab, I have to explain something. This lab utilizes Le Chatelier's principle. Le Chatelier's principle can be used to predict the changes to a system due to changes in pressure, temperature, or concentration. In this lab, we're using concentrations to shift the reaction from the reactants, a copper and water complex, to the products, a copper, water, and ammonia complex, and back and forth again, changing the ligands from water into other things. Now, I know what you're thinking. What's a complex? A complex is made up of a central metal atom or ion surrounded by negatively charged ions in or neutral molecules possessing a lone pair of electrons. We didn't cover this too much this year, but it's very weak, so this is what we're going to be changing in the lab. And a ligand is another nonmetal molecule in the complex, in this case water and ammonia. And I'm going to be using the word complexes a lot in this video. Using 0.5 molar copper chloride, 12 molar hydrochloric acid, and 14.8 molar ammonium hydroxide. So, what is the reaction that's taking place? In this reaction, it's going to be a copper and water complex that's created from copper chloride in solution disassociating into the water into Cl- and CO2+, which then makes the copper and water complex. Adding in the ammonium hydroxide shifts the reaction to the right, with the OH of the solution from ammonia that's disassociated into the water as well, in that complex, as shown here. Becoming part of the complex with water, it makes it neutral, and this makes the solution into a slightly darker color that wasn't really shown because I used such a high molarity of ammonium hydroxide in the lab. By continuing to add the ammonium hydroxide, it shifted the reaction into the complex with water, ammonia, and copper. This was a dark blue color, and it can be seen in the video as it goes to completion, which is what I expected. Now that the reaction has been completed into the products, adding concentrated HCl in solution should change the complexes back into copper and water only complexes because of the H+ ions in solution are what's needed as a product to shift the reaction backwards. This should make it a lighter blue again, but that's not what happened. Because I neglected the Cl- ions in water as well, the original solution was positively charged, so it was unfavored by the reaction for that reason. So in neglecting that I had a strong concentration of HCl ions, the complex made a copper chloride complex as well, made the solution like a greener color rather than blue, which changed the oxidation state of the copper to not have a charge which is favored by the reaction. As well as not as much, but there was some copper and water complexes still in the solution. By adding more ammonium hydroxide to the solution, it shifted back into the completion of the products with a complex of water, copper, and ammonia.